Hello students, I am Dr. Amol Rahane welcomes you to the course Physics Principles and Applications for FYBSc Physics Paper 2 Semester 1. In this chapter, we are studying the physics of molecule. So we have studied the different types of chemical bonds such as ionic bond, covalent bond, van der Waals bond, hydrogen bond and metallic bond. We have also studied the rotational energy levels of a diatomic molecule and vibrational energy levels of a diatomic molecule. So in today's lecture, we are going to study the problems based on chapter 3. Let us start our first problem. The vibrational frequency for a diatomic molecule HF is 1.24 into 10 raised to 14 Hz. The mass of hydrogen atom and fluorine atom are 1.67 into 10 raised to minus 27 kilogram and 3.15 into 10 raised to minus 26 kilogram. Find question 1 force constant K for the interatomic force. Question 2 the energies in ground state and first excited state. First we will write what is given. So what is given? The vibrational frequency of hydrogen fluoride molecule is given, right? So vibrational frequency is denoted by nu and it is given, so it is, we can write it is 1.24 into 10 raised to 14 Hertz. Then the masses of hydrogen atom and fluorine atom are also given, right? So we will call mass of hydrogen as M1. So it is 1.67 into 10 raised to minus 27 kilogram, and M2, that is mass of fluorine atom, it is 3.15 into 10 raised to minus 26 kg. That means the fluorine atom is much heavier than the hydrogen atom. Now we have to find out the force constant K, right? We denote the force constant by K. So we will write, so force constant K, and we have to find out the energies in the ground state and excited state, right? So we have to find out the ground state energy and excited state energies, right? So we will write ground state energy as E0. So we have to find out E0 and E1, right? So two energies we have to find out in this problem. So let us now solve the problem. So first we know the vibrational frequency, formula for the vibrational frequency. So we know the vibrational frequency of the diatomic molecule is given by nu is equal to 1 upon 2 pi root K upon mu, right? So here this K is the force constant and mu is the reduced mass of the system, right? So here this nu, the vibrational frequency is given to us. This 2 pi is constant, and this nu, first we will calculate nu from the given masses and we will put into this equation so that we can calculate K, right? So let us first calculate the reduced mass, right? So mu is the reduced mass of the system. So reduced mass is given by formula mu is equal to M1 into M2 upon M1 plus M2, right? So M1 and M2 are the two masses which are given. So we can put the values. So M1 is the mass of hydrogen atom, which is 1.67 into 10 raised to minus 27 kilogram, into mass of fluorine, it is 3.15 into 10 raised to minus 26 kilogram, divided by 1.67 into 10 raised to minus 27 plus 3.15 into 10 raised to minus 26, right? So here the two masses are given. So to solve this problem, so let us calculate the terms in the numerator. So in the numerator we have 1.67 into 3.15. So we'll use calculator, scientific calculator. So here 1.67 into 3.15 we'll write. So that term is 5.2605 into, so we have 10 raised to minus 27 into 10 raised to minus 26. So these two terms are, we have 10 raised to the power, right? So both the terms, here we have the product, right? So we have to add these two terms, right? So we'll add minus 27 minus 26. So it is, I will write 27 plus 26, so that is 53, right? So I will write 10 raised to minus 53, right? And below we'll do the calculation. So before that, here we have to see the order, right? So in the denominator, what we have, 1.67 into 10 raised to minus 27 plus 3.15 into 10 raised to minus 26, right? So here the two terms, they are not in the same order, right? That means we cannot directly sum, right? So we cannot directly sum of these two terms. So what here we have to do? So we have to convert one term into other format, right? So that, let us first convert either of the term into this format, right? So which is bigger term here? So 3.15 into 10 raised to minus 26 is bigger than 1.67 into 10 raised to minus 27, right? That means we can say the mass of fluorine is higher than that of the hydrogen, right? So it is better to add the smaller term into the bigger one. So we will convert this term into the 10 raised to minus 26 format, right? So I will write, so this term I will convert as 0.167 into 10 raised to minus 26, right? So I have taken this 10 raised to minus 10 power, 10 raised to minus 1 power from here, and that power I have multiplied here, right? So that is 10 raised to minus 1 is 0.1. So I have multiplied by 0.1, so that is 0.167, right? And here it remains 10 raised to minus 26, right? And the next term is as it is, 3.15 into 10 raised to minus 26. Now we can now easily take out the common from the two terms. So numerator term I can write as it is, 5.2605 into 10 raised to minus 53 divided by denominator. Now we can sum of these two terms, we can take out the 10 raised to minus 26 common out of it, right? So before solving this kind of expression, we have to convert this into the same format so that we can take out one term common, right? So 10 raised to power I can take out for common, so it is 10 raised to minus 26 as it is, and I can directly sum of these two terms. So bigger one is 3.15 plus 0.167, right? So that comes out to be 3.317, right? And therefore I can now do the division of these two terms. So I can divide the 5.2605 divided by 3.317, right, which is equal to, so that term I can write here, right. So that term is 1.5859, right. Into, we have to write the 10 raised to power also, right. Now this 10 raised to minus 26 at the denominator, if we take at the numerator, that will be plus, right. So if I take this term at the numerator, so I can write into 10 raised to plus 26, right. Now this is minus 53 and plus 26. If we add these two terms, we will get, right, let us add. So it is minus 53 plus 26, right. So which is equal to minus 27, right. So that is minus 27. So here I can write 10 raised to minus 27, right. So this is the reduced mass, right, and it is in kilogram, right. So unit is kilogram. So this is the reduced mass we have calculated, right. Now we have to calculate the first the force constant, and then we have to calculate the energies, right. So we have already written the formula for force constant, right. So we have written the formula for frequency, vibrational frequency. From there I can modify this formula to get force constant, right. So I can get, right, I can square on both sides, right. So if I square it, is mu square is equal to 1 upon 4 pi square, right. 1 upon 4 pi square into k upon mu term, right. So this term is here. Now I can take all these terms on this side, so we will get k, right. So all these 4 pi square mu term, if I multiply on this side, I will get k on other side, right. So I will write k is equal to 4 pi square mu into nu square, right. So this is the formula for k. Now let us calculate the value of k. So I can write k is equal to, so 4 into value of pi is 3.14 square, right, into mu is the reduced mass that we have calculated, and it is equal to 1.59 into 10 raised to minus 27 kilogram, into the vibrational frequency nu is given, right. So that value is given, and that is 1.24 into 10 raised to 14, right. So bracket square, right. Now we have to solve this. We can use calculator simply, and we can calculate, right. So I can write 4 into this calculation I can do. So it is 3.14 into 3.14, so it is 9.86 that I know, into 1.59 into 10 raised to minus 27 as it is, into, so I have to take the square of this term, right. So square of this term, that is 1.24 into 1.24, so that comes out to be 1.5376 into, so this term 10 raised to 14, so square of this term is, so we have to do 14 into 2, right. So it is 28, so it is 10 raised to 28, right. So therefore we can now do the calculation. So calculation 4 into 9.86 into 1.59 into this term 1.5376. So if you do the calculation, so that number comes out to be 96.422, right, into, now we have the 10 raised to power, right. So it is 10 raised to minus 27 into 10 raised to 28, right. So 28 minus 27, that number comes out to be 10 raised to 1, and that is equal to 10, right. So 10 raised to 1 is 10, and therefore I can write 964.22 Newton per meter. So we have calculated K, the first constant. Now let us calculate the energies of ground state and excited state, right. So we know the vibrational energy of the diatomic molecule is given by, so vibrational energy, so it is quantized, and therefore we can write En is equal to En plus half h nu, right. So here this N is an integer, so it can take values from 0, 1, 2, 3 up to infinity, right. So the ground state energy for the molecule is given by, so vibrational energy is for ground state, so ground state, the quantum number n will be equal to 0 for the ground state, and therefore ground state energy will be equal to E0, and that will be equal to, by putting the value 0 here, right. So we get 1/2 h nu, right. So we know the h, so h is Planck's constant, and its value is 6.625 into 10 raised to minus 34, right, into this nu is given, so it is 1.24 into 10 raised to 14 hertz, right. So these values are given, so we can easily calculate the energies. So let us calculate the energy, right. So it is 1/2 means 0.5 into 6.625 into 1.24. So that number comes out to be 4.107, right. So 4.107 into what we have is 10 raised to minus 34 into 10 raised to 14. So minus 34 plus 14, so that number comes out to be 10 raised to minus 20, right, into 10 raised to minus 20, right. So we can write, so it is nearly equal to 4.11 into 10 raised to minus 20, right. So all the values we are taking into SI units, right. So frequencies is in hertz, so our energy will come into joule, right. So this is energy in the joule. So this is vibrational energy for the ground state, right. So this is ground state energy. We can convert this energy into electron volt if we divide it by 1.6. So 1 electron volt is equal to 1.6 into 10 raised to minus 19 joule, right. If I divide by this quantity, so I'll get the energy in electron volt also, right. So if you want to convert in electron volt, we can convert, otherwise we can leave it as it is, right. So divided by, so this value comes out to be 0.256 electron volt, right. If you want to convert, you can convert, otherwise you can write the values in joule also, right. Now we have to calculate the energy for first excited state. So vibrational energy for first excited state. So for first excited state, what we have, n is equal to 1. By putting n is equal to 1, we will get E1 is equal to 1 plus half into h nu. So that is equal to 3/2 h nu, right. So this is the energy of first excited state, right. And we can then calculate, it is equal to 3/2 into H, we know it is 6.625 into 10 raised to minus 34 into nu is 1.24 into 10 raised to 14, right? So we can calculate, and that value comes out to be closer to 1.23 into 10 raised to minus 19 joule, right? So this is E1, right? Again, if you want to convert this quantity into electron volt, so we can just divide it by 1.6 into 10 raised to minus 19, right? So it is, that value comes out to be 0.768 electron volt, right? So you can write either in joule or electron volt, doesn't matter. But if specifically asked to calculate in electron volt, so in that case we have to divide the quantity by this quantity by 1.6 into 10 raised to minus 19. So in that, then this it will convert into electron volt, right? So if you divide this by this, then it will convert into electron volt, and vice versa. If you want to convert the quantity in electron volt into joule, so multiply the quantity in the electron volt by 1.6 into 10 raised to minus 19, then our value will be converted into joule, right? So this is the first problem. Now let us study the second problem based on rotational spectrum. The internuclear distance between the two protons in a hydrogen molecule is 0.74 angstrom. Calculate the first two rotational energy levels, right? So let us first see what is given. So given mass of proton is given, which is equal to 1.7 into 10 raised to minus 27 kg, and the Planck's constant H is given, so its value is 6.63 into 10 raised to minus 34 joules into second, right? Again, the bond distance, internuclear or interatomic distance is given, so that is, we call it bond distance, so that is 0.74 angstrom, right? So R is given, so R is equal to 0.74 angstrom, and we know that 1 angstrom is how much? So it is 10 raised to minus 10 meter, right? Since all the quantities are in SI unit, therefore it is better to convert all the quantities into SI units, right? Now what we have to calculate is the first two rotational energy levels, and mass of proton is given, right? So we know the formula for rotational energy levels, right? So formula is Ej is equal to J into J plus 1 H square upon 8 pi square I, right? This is in joules, right? When we are, it is in joules, when we have to calculate the energy is in joule, we will write joule. When we are to convert into electron volt, we have to convert it into per centimeter unit, then we will divide this quantity by H into C, right? So if you want to convert into per centimeter unit, if you want to convert the calculate the wave numbers, so you can divide it by H into C. Now here we will calculate in joule, right? So here this J, we call it rotational quantum number, right? So in this H is Planck's constant, it is given, 8 pi square is constant, so we have to calculate I, right? So what is this I? So I is the moment of inertia, right? So we know the moment of inertia formula, I is given by mu into R square, right? So R is given, right? So internuclear distance R is given, so we have to calculate mu, right? Mu is the reduced mass, so from mass of proton is given, right? So mass of hydrogen is given, and from that we have to calculate the H2 molecule, right? So hydrogen molecule, that means H2 molecule, we have to calculate the reduced mass, right? And from that we will calculate I, that is our moment of inertia for this molecule, right? So let us first calculate mu, right? So this mu is given by m1 into m2 upon m1 plus m2, right? Here both the atoms, they are of hydrogen, right? So they are of hydrogen, right? So we will calculate the reduced mass first. So let us calculate mu is equal to m1 into m2 upon m1 plus m2, right? So to m1 and m2 we have both the protons, so it is same. So 1.7 into 10 raised to minus 27 kg into again 1.7 into 10 raised to minus 27 kg divided by again 1.7 into 10 raised to minus 27 kg plus 1.7 into 10 raised to minus 27 kg, right? So here we can easily calculate the reduced mass, so we will just convert. So it is 2.89 into 10 raised to minus 20, so 27 into 27 plus 27, it is 54, right? Divided by, it is direct sum, so we can take out 10 raised to minus 27 common and we can do this sum, right? So it is 3.4 into 10 raised to minus 27. And if we calculate, right, so if I calculate, that number comes out to be this number comes out to be 0.85 into, so this minus 27, it will go up, so it is 10 raised to plus 27, it will become 10 raised to plus 27, right? So 10 raised to minus 54 plus 27, that will be 10 raised to minus 27, right? So it is kg, right? So that number is 10 raised to minus 27 kg. Now we have to calculate the moment of inertia, which is given by mu into r square, right? So r is given and mu we have calculated, so it is 0.85 into 10 raised to minus 27 into r is given, so value of r is 0.74 into 10 raised to minus 10, right? And bracket square. So if we calculate this value, so this quantity comes out to be 0.85 multiplied by 0.74 into 0.74, so that comes out to be 0.465, right, into 10 raised to minus 27 into 10 raised to minus 20, right? 10 raised to minus 20. So minus 27 into minus 20, it is minus 47. So I'll write directly. So I'll write minus 47 here, right? So minus 47. So if I convert, so I'll convert it into, let's say I'll write like this, 4.6 into 4.65 into 10 raised to minus 48, right? So that quantity is in kilogram into meter square, right? So SI unit of moment of inertia is kilogram into meter square, right? Now we have to calculate the energy for the first two rotational energy level, right? So first two rotational energy levels, they are given by J values, right? So first value is for J is equal to 1. If I put J is equal to 1 in equation for EJ, which is J into J plus 1 H square upon 8 pi square into I, right? So this is in joule, right? Now we have to calculate the first value, so that is given by J is equal to 1, right? So J takes only positive values, right? So for J is equal to 1, we get E1, which is equal to 1 into 2 h square upon 8 pi square I, right? So which is equal to h square upon 4 pi square I, right? So that value, now if we put the values of h, so h is 6.63 into 10 raised to minus 34 bracket square divided by 4 into 3.14 into 3.14, so 3.14 square into I. So I value of I we have calculated, it is 4.65 into 10 raised to minus 48, right? So we have to calculate this value and we can calculate this value, right? So if we square this term, right? So square of this into square of this is 10 raised to minus 68, right? Again do square of this, then square of this, and right? If we take this 10 raised to minus 48 at the numerator and we can calculate, so we will write the calculated value of E1, it is 2.4 into 10 raised to minus 21 joule, right? Now we have to calculate the energy of second energy level, right? So we can put J is equal to 2 into this equation, above equation, right? So we can calculate, so it is for 2, it is 2 into 2 plus 1 h square upon 8 pi square I. This term is as it is, and therefore what we will get is 2 plus 1 is 3, 3 into 2 is 6. So it is 6 h square upon 8 pi square I. Now we have to calculate the second energy level. So it is E2, by putting J is equal to 2, we will get the second rotational energy level, which is equal to 2 into 2 plus 1 h square upon 8 pi square I, right? So which is equal to 3 into 2 is 6 h square upon 8 pi square I, and therefore we can calculate, it is 6 into h square is 6.63 into 10 raised to minus 34 square divided by 8 into 3.14 bracket square into I. So value of I is 4.65 into 10 raised to minus 48, right? If you calculate this value, so this value comes out to be 7.2 into 10 raised to minus 21 joule. So you can do the calculation and you will reach at this value, right? So we have calculated the two we can say first two rotational energy levels for the diatomic molecule.